Hello, everyone. I'm Akiba. I guess I was already introduced, which kind of messed up my original plan. But anyways, yeah. So I run a small web shop called Freak Labs, and I'm one of the founders of Tokyo Hackerspace. And also, recently, I'm a design consultant for the United Nations, which is very interesting. And I wanted to talk to you today about open source hardware and humanitarian applications because I've had a bit of experience doing it for the past year and a half through Safecast with radiation monitoring in Japan, and more recently with the United Nations, specifically UNESCO. So the question I want to pose is, why do humanitarian applications need open source hardware? And rather than tell you why, I want to show you through my experience, especially through Safecast. Let's see. Well, it's not playing. But anyways, this is a video clip, and I will play it in a second. But it's probably best to give you some context. This video clip was taken about 2 weeks after Fukushima started blowing up. And at that time, we didn't have any information on what was going on. The government was just saying everything is safe outside the evacuation zone. But there were some farmers about 30 kilometers outside the evacuation zone that were really nervous. So some people locally in Tokyo wanted to go up there, and we were lucky enough to get 2 Cold War era Geiger counters from Dave from Reuseum. And so one of them we gave to those farmers to take up to the area called Itatemura, just to measure there and kind of put the farmers at ease. And this video is from that time. So yeah, so this is in Itatemura. It's like about 30 kilometers outside the evac zone, and the government said it was safe. So this is indoors. And this is outdoors. So, okay, that's enough. So the funny thing about that experience was that the farmers actually called us and told us that the Geiger counter was broken, and we were like, why is it broken? And it's like, it doesn't beep anymore. Like, what do you mean it doesn't beep anymore? And it just makes a constant sound. We were like, you should probably get out of there. So after that experience, then we decided that, within Tokyo Hackerspace, we decided that we couldn't really trust anything unless we kind of measured it ourselves, and so we kind of formed a group to start doing radiation monitoring. And we ended up hooking up with another group called RDTN, and we formed Safecast. So RDTN was run by Joey Ito and Sean Bonner, and then after that we formed Safecast, and we started doing radiation monitoring in Japan. And one of our first times out, we went to this area called Koriyama, which is about 100 kilometers outside of the evac zone. And this was supposed to be very safe. But the residents of Koriyama were complaining that people from the Atomic Energy Agency would go there in full biohazard gear and measure the area, and then they'd leave without telling the residents anything. And the residents were really just freaked out by it. So they wanted us to go there and measure, and so we did. So this particular clip is from a kindergarten playground that we checked. Yeah. Next one. Yeah. Okay. So this is the kindergarten playground, and if you look at the dial on the Geiger counter, it's sitting on a concrete wall of the playground where the kids eat lunch at, and it's reading about 52, 54 microsieverts per hour. I have the identical Geiger counter right here, and in this room, it's reading about 0.1 microsieverts per hour. So in that playground it was like on the surfaces is roughly 500 times like the background air radiation, and which means that a radiation plume passed through there and left a lot of fallout. And when the residents saw that, then they were like, oh my God, and then they started an activist group, and they actually, of their own actions, they decontaminated the area. And there was a really famous time where they took the decontaminated soil, put it in plastic bags, went to Parliament, and threw it onto the table of Parliament in front of the politicians and said, "What are you going to do about this?" And, well, the great thing was that was on TV, and when the TV was panning onto the bag, on top of the bag there was a Geiger counter, and that was like, I was like, "Peter, isn't that your Geiger counter?" And then, so that was really great. But anyways, I wanted to use that just kind of to lead into some of the work that we did using open source hardware in this particular application. So when we formed up the group, we didn't really know what we wanted to do. And we only had like 5 Geiger counters out of all of us. And the question was, how can we use that to its maximum potential to help the most people? And so we ended up, the first thing we did is we decided to put it on cars, and we duct taped a Geiger counter to a car and took iPhone pictures as we drove around. And because the iPhone embeds like GPS metadata inside. And so we could just kind of post those on Google Maps. And that was okay, but it didn't scale very well. And so the next thing we did was, like, I put together a small circuit using an Arduino and, Arduino compatible, sorry. But it's like the Arduino environment, which is just the most wonderful environment I've ever used. And it's making me really lazy because all the libraries are, already working. But I used an Arduino, I used an SD card, and I used the GPS and interfaced the Geiger counter to it, and used that to just put together a prototype of a geotagging Geiger counter. And this was the first actual, so I milled a circuit board on my PCB, and it was working, and then we were like, oh my God, this is gonna, something's gonna come out of it. And I got the PCBs made at Bare Bones PCB, which they do 24-hour turns. So within 1 week, we had working hardware, working software, and we had a geotagging Geiger counter that we were mounting on the cars, and we were driving around, and we'd collect 5,000 to 10,000 data points per drive around particular areas. And so we ended up collecting, so this is the mounting onto the cars on the Pelican case, using Pelican cases. And we ended up collecting 4 million data points across all of Japan, and we ended up with the most comprehensive set of radiation data, I guess, outside of the government in Japan. And currently it's being used for academic research. And, oh, thank you. But actually, the main point isn't that, oh, this is a great application. I think the main point is we didn't use anything special. I mean, this is technology that's being used within this open source hardware community, and it's like, it's very standard. It's a GPS, an SD card library, and and a headphone jack, right? It's all like just standard libraries that you get when you download the Arduino environment almost. But with the application, we also got a lot of perks too. So people were giving us cars. Tesla would allow us to take the Roadsters out at nighttime. And so we were measuring the Tesla Roadsters, and we actually, one time we raced a Ferrari on the streets of Tokyo, and we just blew the Ferrari away. I think the owner of the Ferrari must have been crying because the Teslas are just, the torque is so high. So yeah, there can be some fun times there. And all the design files and the source code, it can be found on my GitHub. I just recently started up the GitHub so I could centralize all the files. So the documentation is a bit sparse, but all the files are there. So along with the mobile radiation measurement, 2 minutes. All right, we're going to move through this fast. So along with the radiation measurement, we did stationary measurements. This loads data up to Patch Bay. And I ended up kind of putting together this board that would take radiation data, load it up to Patch Bay to measure radiation over time. And we ended up getting, like after we made this, then we got a donation from a company called SoftBank, and they donated $1 million to this project after we showed it to them. We were like, wow, $1 million. Yeah. When we were at the meeting, we were like wondering, all right, so whose bank account can handle $1 million? And then, So it ended up, so Keio University ended up as a steward for the money, and we started deploying these across Japan. And we ended up with I think the largest non-governmental radiation monitoring network in Japan. It's with about 330 nodes. Let's see, and it's one of the things I really like is you can click on the nodes and see the data, but it's all open data. It's a CC0. It's on Patchbay, COSM. And right now, academics are using it. They're measuring the time rate of change of radiation. You can actually see it's dropping faster than the decay rate, faster than the decay rate of cesium, right? And that's because they're finding that it's because of rain washing away the contamination. So I think that's one of the really interesting things, and I'm proud to see, like in the future, then it's not just the decay rate. You can actually the decontamination time is faster. And sorry, these are the files. It's on my GitHub. And you can find the radiation map on Yahoo. And finally, the UN project I'm working with is called Arashi. It's for weather monitoring. Right now, you can see there's a lot of weather monitors all over the world, except Africa, which is like kind of a black hole for weather data. And so that's, we're going to try and change that. And sorry, I know it's almost time, but this is kind of interesting. So I talked to the UN, and in order to work with them, I said, okay, let's do a weather. I can help with a weather monitor project, but it has to be open hardware. And they're totally cool with that. And so I think this is going to be one of the first open hardware projects that UNESCO will be publishing. And an open hardware weather monitor has just so much potential for great things, because you can put them on like public schools, you can teach about it, people can contribute to it, and also the price will hopefully be low enough that it can proliferate. And so I think like the potential for open hardware is just in this application is just unbelievable. And so and this is just some of the current weather stations in Africa look like this. And so like it's just like they're just very primitive, and they're functional, but they're not automated. So that will be on my GitHub also. It'll be open weather monitoring, and it's a joint project with UNESCO. And I just want to say thank you to everybody and the open hardware community. The open hardware community has the power to really have a huge impact in the world. I think there's a power and a responsibility to have a huge impact in the world and to improve the lives, to save the environment. The amazing thing is it's all possible, and it's just using the technology that we're playing with every day. None of this technology is fancy. Like it's all just the standard, like almost the standard libraries that come with the Arduino environment. So it's just amazing. I think it's amazing. Thank you very much.